on the quiz as well, because it's all about patterns. It is not a real long quiz, okay? It's just like front and back of a page. But you have to know the Pythagorean theorem really well, and you have to know your two special right triangles. So make sure you're working with it. Guys, work with each other. If you get your homework done tonight, I will be home later in the evening. This would be a great time if you have any questions to call and ask questions, that type of scenario. Yes, sir? No. All right, we're going to look at number, which one? 22. Okay, great. All right, on 22, it's the following. It says estimation. A triangle loom is made from a wood strips shaped into a 45, 45, 90 triangle. So they showed the diagram on there. So here, I'm just going to draw it now. Here's our 45, 45, 90. It says, and pegs are placed every ½ inch along the hypotenuse. So this would be like something like this. This is at ½ inch increments. And they tell us that they're placed at a ¼ inch every leg. So whatever we're doing here with this, these are all at what? A ¼ inch spacing. Okay, so that's the spacing with it. So suppose you make a loom with an 18-inch hypotenuse. Approximate how many pegs will you need? So first of all, if I'm at 18-inch hypotenuse, how many pegs would I need approximately for the first one? Should be about 36, right? So about 36 pegs, about, right? Because all we have to do is go, what, 18 times 2. All right. Now, what's going to happen to me next? What's going to be the most helpful thing here? Work with me. What's next? What do I need to know? I'm going to do length for the legs. How in the world am I going to solve for the length of the legs? Yeah, we're going to use the generic triangle, right? Guys, we're going to use, and no, when I say generic triangle, this is exactly what I mean. Here is an isosceles right triangle. You can put a 45 degrees in there if you want. I have x, x, x for 2. I only do this so I can see our pattern, right? So if I'm given the hypotenuse, I know I divide by the square root of 2 to get the leg. Okay, so we know this is 18 divided by root 2. Now, that's not a lot of help. Let's just go there. It really becomes 9 root 2 over 2 when you're simplifying things. Wait, I say that 9 root 2, excuse me. Make sure I simplify that better. If you simplify it, but let me show you to make sure we're all on the same page. All I did was rationalize the denominator, which gives me 18 root 2 over 2, which is what? 9 root 2. Okay. Now, I need that to be in inches, correct? Now, this is one of those times, because remember, we're doing approximate. Wouldn't it be smart if I had my calculator out? All right, so someone punch that into your calculator real quick. What is 9 times the square root of 2 about? All right, so 9 times, yeah, that sounds about right. I got about 12.7279, blah, 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 blah. Very technical math term is blah, blah, blah. Get that, all right? But what do I have to do with that? Because I'm looking for the number of pegs. There's, how many of them would you need about an inch? 4 of those, right? So wouldn't I multiply this by what number? 4. 4. All right, so take what's on your calculator and go times what? So take this value, I'm going to go 12.7279 times 4. What did that get us about? 50.9-ish per side? Okay, so I would round that up to probably what? 51. Well, I have 2 sides that are going to be at 51, and I have one side that's at 36 pegs, right? Now again, this is approximate. Are we right on? No, but close enough for what we're doing. So I get 102 plus 36. I get 138 pegs. All right, if they said pegs, nails, which would be about the same thing, right? That's about what it should be. Does that make sense? Yes. All right, SJ, you had a question? For which one? 19. Oh yeah, let's look at 19. Now remember on, I think was it like 17 and 19, you only had to do the perimeter only, correct? Okay, first of all, what do we need to draw? Diagram with the diagonal drawn in. Because look here, it says in here, find the perimeter area of each figure. I gave you directions to only find the perimeter. Area we'll do later, so I'm not worried about that. It says a square with a diagonal length of 18 meters. All right. What's the definition of a square? A quadrilateral, that's what? Got right angles, and what else? All the sides are the same. Perfect. So when I do that and I draw in a diagonal, oh, look, what type of triangle did I just form? Isosceles right, which is also known as our 45, 45, 90, correct? So if that's the case, I'm looking for, and it just says find the perimeter. So I just need to find the length of one of the sides and then multiply the number of sides by what? 4. So if I'm doing that, I'm given the hypotenuse. How do I get to the leg of that isosceles right triangle? Divide by what? Square root of 2. So I got 18 divided by the square root of 2. Oh, look, rationalize the denominator. This is weird that these were the same numbers, guys, the two problems. All right, but we got 18 root 2 over 2, which gives me what? 9 root 2 meters. But when we're working with this, what are we going to need to do next? Just find the perimeter, which is 4 times the length of one of the sides. I got 36 root 2 meters. Is that what you guys got? Didn't say the triangle. It says find the perimeter of a square with the diagonal of 18 meters. So you got to remember what's really being asked on there. The square's perimeter. And remember, perimeter does not include the diagonal because perimeter is everything on the what? Outside, not the inside. Good clarification on there. Okay, I saw other hands up. Hallie and then Rachel.
Could you do 17?
I can totally do 17. Can you?
I don't know. That's why I'm asking you to do it.
All right, with this one, draw what? Draw a diagram. And it says it's a 45, 45, 90 triangle with a hypotenuse of 12. All right, so hopefully all of you marked that away. And I think it's 12 inches, correct? Okay. 12 inches. Now what? Got to find the leg, right? How do I do that? How do I go from the hypotenuse to the leg of a 45, 45, 90 triangle? Yep, divide by root 2. Bigger to smaller, you divide, right? So we divide by root 2. Okay, so I'm going to go 12 divided by root 2. Oh, look, there's a reason why Mrs. Gregerson made you learn to rationalize the denominator before this chapter, right? So we're going to multiply by root 2 times root 2. I get 12 root 2 over 2, which gives me what? 6 root 2, and that would be in inches. But this becomes 6 root 2. This becomes 6 root 2. All right, perimeter. Let's talk about how you calculate that. You add all your sides together. But we also need to remember what we know about radicals. You have to have the same radical in order to combine, right? Nothing can go with that 12 with the 12. But 6 root 2 plus 6 root 2 gives me what? No. 6 root 2 plus 6 root 2 does not give you 6 root 4. It just gives you what? 12 root 2.
Why don't you add that?
Because we're not multiplying. You don't add radicals. It's just like doing a variable. That's the same thing as doing, wow, as this is all on here. Thank you. Going here, closing here. All right, wrong one. Hello. All right. Can't wait for them to watch that later. All right. But with this one, remember, that's the same thing as like going 6 plus x plus 6x, right? Which gives you what? 12x. So it's doing the same thing. Because remember, we're adding, we're not multiplying. All right, and then make sure you label it. That's as good as it's going to get. 12 plus 12 root 2 inches. That's in simplest radical form right there. Yes, Cormac. Number 45. What's number 45? Oh, this is fun. This is review from the back stuff. This was when we talked about the perpendicular bisector and the angle bisector theorems. This is chapter 5 coming back to Honest. Everyone's favorite chapter is chapter 5. That's the circumcenter one, the in-center. Okay, see why that's not my favorite chapter either? Like, yeah, I totally agree with you guys. All right. Remember, I even said, like, this is not my favorite. Remember, I said, I don't like this chapter. It's like important stuff we had to know, but it was like weird dumped stuff all together. Oh, no, it's not as, no, not really. All right. It's, trust me, it's torture no matter what. All right. For this one, it says, use the diagram. So the diagram looks like this. And then we're given some segments right here coming down. I think we're like right here. And we have Q. We got to make sure we have here V, T and U. Then we also have P, S, and R. All right, now let's label what they know. They say you're given the fact that segment UT is equal to TV. So I know these two are the same. The measure of angle PQS, so I'm looking at this angle right here. I'm going to use a different color here. So PQS, that angle is 42 degrees. I want to know the measure of angle VTS. Fun. So I'm looking for this angle right here. VTS. Wow. What do you know about ray QS? It's going to be what? I heard it. It's an angle bisector. Because remember, if I'm the same distance away from the side, so if these two are the same length, that means I am on the angle bisector. So that means these two angles are what? The same, right? So you agree with me. Let's see if I can enlarge this, but I think it's going to make the writing a little bit harder. This one is going to be 42 degrees as a result, correct? Guys, can I find the measure of this angle then? Can I just go 90 minus 42, which gives me 48 degrees? Yes, no? Does that work? And now remember, I'm looking for this one, but aren't they a linear what? They're a linear pair, so can I go 180 minus 48? Now, there is another way you could have done that one. Could you also use the fact that the two remote interior angles add up to the exterior angle? What's 42 plus 90, guys? That would also work.
For this one, I did something that is like worked in the past, but didn't work this time. The previous problem, we knew that angle of QSR was 65 degrees. So I used it as another angle on the quadrilateral.
All right, you have to be careful. I mean, you could use the quadrilateral stuff if you wanted to, but I wouldn't. I mean, on this one, it's just flat out using your angle bisector theorem was so much faster when you're working with it. Plus also the fact that you're given, really, the fact you have those two congruent triangles, you could have used that as well.
I know, for some reason it didn't work. You can see how that's easier.
But here's the part of the reason why you can't use number 44 to do number 45, because PSQ is not 65 for number 45. So you were using the number from the previous problem. Not unless it's given in the directions. Same diagram, but doesn't mean they're going to have different information on it. We've done a lot of diagrams like that before, right? So yeah, if it was the fact that the angle you're saying to it, it would have to be up in the given directions. If that's going to stay for all of them. So nope, good questions on this. All right, any other questions on homework? Rachel? You said 23? No, where is number 23? Back of the book. So no, I wanted you guys to look at 23 in the back of your book. Because on 23 it says the angle measures are 1 to 2 to 3 are the side lengths of the ratio 1 to 2 to 3. Explain your answers. And this actually, number 23, do you notice something that's on there right now? Guess what it's going to be on tonight's homework as well. Hint, hint. Make sure, because it works with the 30, 60, 90 triangle. It was a mistake on the answer key. But remember, odd number ones, if I ever assign those and they're not in the answer key, just where's your fail-safe thing you can look? Back to the book, which means you actually supposed to have your book at home, right? But you'd have to be able to do that. But that's where, so that's why it was on the answer key. So don't worry if you do not get 23 on tonight. You'll be able to get it tonight and make more sense. With me on that, guys? Okay, awesomeness on there. All right, any other last questions on there? Are we good? All right, so friends, here's what we need to do. Let's get ready to take some notes. Are you guys good with that? All right, I'm going to pause this, and then we're going to have, what I need to actually hear.